Excuse me. Okay, we got the function f of xy equals x divided by y. And we want to look at the possibility of a limit as delta x and delta y both approach 0 of the function f of xy. Okay, is there a limit? If so, what is it? If it doesn't exist, why not? Well, we can show pretty easily that this limit doesn't exist. Now, it takes a little experience and a few examples to understand how we might do this. I was tempted to explain how we come to this, but I don't think it'll be obvious until we actually do it, so I'm not going to do so. Okay, so we're going to approach 0 along two different lines, okay, because the limit only exists if it exists no matter how you approach x and y equal to 0. Okay, and I've got a delta x and a delta y here. And really, I'm just going to call that limit as x, y goes to 0, okay, because that other one wasn't correct the way I wrote it. Okay, along the line y equals 0.2x, okay, what can you say about x over y? Well, if y equals 0.2x, then x over y is x over 0.2x. So that if y equals 0.2x, f of xy is x divided by 0.2x, and that simplifies just to 5. So if you approach 0 along this line, the limit is 5. Okay, so approach 0. I say approach 0, I should say approach the origin. If we approach 0 along this line, the limit is 5. If we approach 0 along this line, on the other hand, well, y equals 2x. So what does x over y equal? It equals x over 2x. Okay, so approach along the line y equals 2x. X over 2x is just 1 over 2. X is divided out. Okay, and this proves that the limit doesn't exist, and we'll be a little bit more explicit about that in a minute. But approach the origin along this line, the limit is 1/2. Okay? This proves the limit exists. And let's be specific. I'm going to say approach zero, 0 along points at distances, say 1/2, 1/4, 1/8, 1/16, etc. from the origin, alternating lines. That is, we start on either line at a distance of 1/2. Okay, if we start on this line and this distance is 1/2, then we know that the value of this function is going to be 1/2. And then if we go to the point where the distance is 1/4, but we switch from this line to this, we know that the value is going to be 5. And then we switch back to this line at a distance of 1/8 from the origin, and we know that the value is going to be 1/2 again. And then we go to a distance of 1/16 from the origin, the value is going to be 5. There's no limit to that sequence. Okay, so the values would be like so. Okay, we would have value 1/2, 5, 1/2, 5, etc. No limit. Because there's no delta within which we could confine any possible limit to within epsilon. Okay, no, not possible if epsilon is less than 1/2 the difference between 1/2 and 5. And if you understand epsilons and deltas, you should think about that. Okay, that started out in parentheses, so I guess I better end it in parentheses. Now, another question. What if we had g of xy equals x over y squared? What strategy could we use to test whether this has a limit or not? And I'll give you a quick hint. The strategy of approaching along either of these lines isn't going to be very helpful. If we approach over either of these lines, we get an infinite limit. So, and you can test that out. You might want to think about that. If I approached, if y was 0.2x, then what would this be? And what would that tell us about the limit of this function if we approached along this line? And if y was 2x, what would that mean if we approached along this line for this function?